So my name is Dominic Matt. I'm the head of Fraunhofer Italia. Fraunhofer is the largest research institution for applied research in Europe, and we have about 22,000 scientific collaborators, and I'm responsible for the Fraunhofer Italia part. We are obviously smaller, and I'm also a professor at the Free University of Bolzano. Bolzano is a city at the very north of Italy, at the border to Austria, within the Alps. Maybe you have heard about it. It's a nice place to go skiing, so it's quite a pleasant place to stay. I introduce you briefly my team I brought with me. It is Irene Paradisi. She's the head of Building Efficiency Group at Fraunhofer Italia. Then we have Patrick Dalla Sega. He is a scientific collaborator also at Fraunhofer Italia, and Mariana Marchesi. She's my PhD student, currently doing her stage abroad at MIT. So, today we are talking about a completely different issue, as Chris mentioned before in Florence. I'm coming from the manufacturing systems side, and so usually I'm really busy with manufacturing system issues, but we established, as we see that currently in Europe we have more and more emphasis placed on architectural design and building efficiency, especially on the processes, and I will talk about this later. It's a big issue at the moment in Europe because everything is changing at the moment, not only due to our financial situations, but in general. And so we established a research group within Fraunhofer Italia, which is applying methods that are known from manufacturing and from mechanical engineering design to the building construction. So what we're going to do within this tutorial, I'll give you a brief introduction in general, and then Mariana will take over, and she will just briefly recall the principles of axiomatic design. Then we do an introduction into our workshop. This will be done by Patrick Dalla Sega, and then takes over Irene Paradisi with the workshop activities, and there we will get involved a little bit more into these issues. But what are we going to talk about? Well, maybe I just mention a little bit what is going on in Europe so far regarding the building sector. I think we are quite different with regard to the building sector than the United States, at least from what I could see here so far. We have a situation of a very high individuality regarding housing, planning, design, and also realization. And a special issue of European living is that it is all built for eternity. So it is quite a different approach also with regards to materials, technologies, and so on. So it is not directly comparable to what is the building construction in the United States. But anyway, what we see is currently we have an increasing of complexity in building. This is due to the fact that in Europe general we have a policy of energy efficiency. And especially in Italy, at the moment, we have been imposed by law to have a minimum building efficiency for every new house that is built. So it is quite hard to do this, because usually architects were used just to do a nice design and then build up the building, and then at the end maybe it was just checked whether it was energy efficient or not. But this is not possible anymore. So we have in advance planned it in a way that it satisfies a certain basic energy efficiency. And there, in our part of Italy, in the very north, where Bolzano is located, we are quite leading at the moment because we have a lot of experience, especially in this area, regarding this energy efficient housing. Then we have an increase in the individual customer needs. Although we have done a lot of efforts in standardizing individual housing, it is still quite a problem. This is also due to the fact that, especially in Italy, you must know that about 80% or more than 80% of the population is a house owner. So and from this 80%, about 90%, 80 to 90%, are people that live in multifamiliar houses. So just imagine doing a refit of a multifamiliar houses with all single parties in there that are owners, and you have to bring them together in order to reconstruct, refit. It's quite a big issue. So you can imagine that it requires a lot of consents to do something like this. It's very complex. Then we have complex and changing partner networks. About 95% of the gross demand product of Italy is done by smallest and small companies. And so you can imagine the most part of the construction companies are very small, and therefore they have to do the realization of the buildings within networks of partners. But bringing these guys together with all of this caching, and you know there's a little bit also within the Italian culture, there's a lot of this caching around, so it is quite also a complex task. Then, of course, the limited resources at the moment, due to the general financial crisis and the debt crisis, in general, building and construction is really down in all Europe, especially in Italy. And therefore, of course, the process efficiency of building is also getting much more important. Then increasing time and cost pressure, of course, and an increasing quality awareness that is coming from the customer. So we see we have, in general, a quite complex situation, and we know that we are dealing in Axiomatic Design with complex issues. So it is a great platform for us to do some exercise on Axiomatic Design, and that's what we want to do, especially to collect all the requirements that are necessary to really do this job properly. Now, regarding the state of the art, we have the situation that in manufacturing, and axiomatic design is more coming from the mechanical engineering and manufacturing part, that's what I'm talking about. There we have a certain degree of standardization, although naturally all manufacturers would now scream and say, no, that's not true, we have a lot of variety. But against the situation of single projects like we have it in construction industry, I think it's quite nothing. So we still are quite standardized, and usually research and development is based also on a certain market research, on certain feedbacks, and there we have quite good interfaces to what customer and market wants, and then these can be transformed into customer domain, functional domain, physical domain, and so on. I don't have to go into these details. I think you are familiar with this. Then on the other hand side, we have construction industry, and this is very strongly project driven, and we don't really know who is the customer. In the end, there is the customer who buys the house, but does he or she know really what she wants regarding all the single details? Normally not. The investor, the customer, relies on the architect. The architect has a lot of know-how regarding the design, but especially functional planning is not his main focus. So there are suppliers that have certain technologies that they are using. We have general constructors, we have the public, we have project managers, we have government, we have neighbors, all people, all stakeholders that are in some way influencing the decision of the architectural design. So we have quite a high product individuality and all these different actors with different objectives. Now, The problem of the traditional process as we have it is that we have an input giver. This is the investor that says, well, I want to have more or less something like this. Then the architect that does a first design. Of course, there is some kind of feedback loop between these two. And finally, a project manager. But we see at the moment a situation that there are all walls between them. So this is not a very, it's not a good osmosis between these areas. So what is the approach that we want to do is that we have a more collaborative design in an early interdisciplinary building team, where all the actors speak the same language and have the same objectives. So regarding the tutorial structure, we now will try to do a work regarding the single, let's say the single roles that we have: the investor role, the architecture role, and the project manager role, and we will form then groups. I think it will be basically 2 groups, and with always one of you being an investor, an architect, and a project manager. And so we will go through this design, axiomatic design, together with you, and try to show how we come from the customer domain to functional and physical domain. We just leave out process domain because this would be too complex to do within this tutorial. Well, this was a first introduction. The next steps are as shown here on the slide, and I would just hand over to Mariana to just very briefly just summarize and introduce about axiomatic design. Thank you very much.
Now we are going to review some aspects, the main principle of axiomatic design. Is a design theory developed at MIT in the 70s by Nam Su. In axiomatic design, all the good decisions involve the same principle. This principle can support the designer to develop a good solution. The design process is an interplay between what you want to achieve and how you want to achieve this. So the process involves, you can see, 4 domains: the customer domain, the functional domain, physical, and the process domain. This process is an interplay between the 4 domains. We are going to see the main process. The process, the designer develop the mapping, zigzagging, and top-down decomposition between what we want to achieve and how to achieve it. So, the designer starts with defining the design intent and develop a first solution according to the functional requirement. After, he comes back in the left domain and develop the functional requirement in a specific way, and develop in the right domain a solution according with functional requirement. So the process continuing until the solution is completed. Now we have an example, a bus seat. So different customer attributes defined different attributes. You can see the seat and bus manufacturer say we want a maximum sale. The maintenance requires a minimum repair, and the travel requires maximum comfort. So the customer attributes are translated in the functional domain. The designer defines the functional requirement. So for the maximum sale, the functional requirement become seat should be cost effective. For the minimum repair, the functional requirement become seat should be easy installed. And for the maximum comfort, seat should be comfortable. Designer define a solution according with functional requirement and define this solution in terms of the design parameter. So the design parameter are seat with cheaper material regarding seat should be cost effective in the functional requirement. And you can see about the installation, the connection will be more convenient, and the material inside the body will be replaced. This solution can check according with the first axiom in order to evaluate if the solution is a good solution, or if it is a acceptable solution, or if a bad solution. In this case, you can see the design matrix is a diagonal matrix, so the solution is a good solution. The designer can develop in the lower level the more detailed functional requirement and continuing the solution in a more detailed solution. Now we are going to develop the lower level for one functional requirement, only one. So in case of seat should be easy installed, the functional requirement lower level is defined in this manner. Installation should be easier, and the assembly time should be shorter. The designer defines now a solution according with functional requirement. And the solution that designer defines consists in a designer without treat and a designer with a joint base part. This solution is a good solution. You can see the design matrix is a diagonal matrix. So the decomposition can consider another functional requirement in the functional domain. Now we are going to see some aspects about the case study in the building sector and the application in axiomatic design.
So now I would introduce you to the case study. I would explain our case study, which we use as a guideline to have some information, some data about how then to elaborate the parameters in subgroups. So the case study consists of a hotel expansion project located in Bolzano, which is in the northern part of Italy. The overall cost of the building is around 3 million euros. And Bolzano, as said by Professor Matt previously, is located to the Alps, and this requires energy efficiency and other aspects which we considered in the case study. So now here we see the building. The building was erected in the year 2009. Here we see the existing building, the existing entrance and the reception. Here we see the new expansion project, especially the 12 double rooms here, 12 double rooms on the upper level, then a swimming pool, a wellness area, and the dining room expansion. But these aspects I will explain more in detail later on. And here we see the expansion project from the south. One can immediately recognize that the new building doesn't shade the existing one here. And the investor, which in this case is the owner of the building, expanded the building for plus 48 guests, which means 12 double rooms in the second basement level, 12 double rooms in the first basement level, and every double room can accommodate up to 2 persons. So here we see that the building was built or was erected to the south orientation of the expansion project. This is the existing building, the existing hotel, and here we see the expansion project. This is now the ground plan of the second basement level. Here we see the second basement level in detail. Here there are the room sections. Every room consists of a modular area of 30 square meters. So every room has the same size. The rooms can be changed from double room to suite by flexible walls. Here we visualize the accessibility to the building, which means the accessibility for use the building, and accessibility during construction, which is a very important aspect, which has to be considered in the planning phase. Here there is the machinery room for the swimming pool in the upper level and for the wellness area in the upper level. The size of the door was chosen to can install or you can bring through the door the machines, the plants, and not only for installation but also for maintenance. And here we see accessibility from customer parking. The rooms are easily accessible with a new parking area located here. So accessibility during construction means also that cranes or building equipment should easily be accessed or transported to the construction site. Here there is the accessibility during construction, and material and equipment can be brought through the rooms also during construction. The level before was a level below the existing building. Afterwards I will show you the section, and in the section we see that the expansion project utilized the slope as an advantage, not as a constraint. And therefore there is a new level below the existing building. So now we see the ground plan of the first basement level. Here we see the swimming pool, as mentioned before, the wellness area here. Here we see the outdoor zone of the swimming pool, the sunbathing area. And we can say that these facilities are located in a central position between the existing building, and the new expansion project here. Another thing is here that the shading stripe is very small. This because the height of the second basement level, or the height here, was chosen in an appropriate way, not to shade the sunbathing area for the swimming pool. And the rooms are also modular with 30 square meters with the same size every room, and the accessibility during construction is done here by crane, because here we are on an upper level, and therefore we can access, or we can bring materials to the construction only by crane here. So now we see that every building area, let me say, is accessible from light and from the sun, and the swimming pool has an outdoor area. The rooms are accessible or from the sun because they are south located. The wellness area has also windows, and the dining expansion we see later on is a level higher than this level. So here we see now the ground floor and the dining area, as mentioned before. The dining area has also windows on both sides for daylight utilization. And here we see the roof of the new wing. This, during construction, this can be used for storing materials and maybe construction equipment. And construction site is accessible here from this side. And now we see the section of the building. As I said before, the second basement level is a new level. The existing project had only the first basement level, and this to use first for environmental integration, and second for use the slope as an advantage. Every area is located outdoor. But the machinery room is under the ground. So the machinery room can be hidden, because it is not a pleasant area to show. As I said before, the building is located to the south. This has the advantage because we are in the Alps, and in the winter the sun is used for heating reasons. So we can minimize energy consumptions by utilizing in an optimized way the existing energy forms, the sun. So now I show you a summary of the things I said before. The extension of double rooms. The double rooms consist of a large wooden lodge. Lodge is a material which has a high durability. Flexibility was introduced in the building with a displaceable walls, so you can change bedrooms. You can change rooms from bedrooms to suites to accommodate different types of customers. Extension of the swimming pool and the wellness area. Both facilities are located in a central position. This has advantages for accessibility, for example. People or guests accommodated in the existing building can access the facilities easily, and also people accommodated in the new expansion project in the new double rooms. An outdoor and indoor heated swimming pool. As I said before, the sunbathing area and the wellness area. And the expansion of the dining area was done to the daylight. And obviously, if you expand the rooms, you have also to expand the other facilities. And in this case, the swimming pool and the wellness area are new areas, and the dining room had to be expanded for accommodating or for hosting more plus 48 guests. So now I would give the word to my colleague Marianna, which introduce you to the framework. We developed a framework in Axiomatic Design, introducing you to elaborate then the parameters in subgroups.
In the case study, the customer require increase of his income. So the designer transform with customer attribute in the following functional requirement to increase the accommodation activity. And how is possible to increase the accommodating activity in this case? The design solution is a bedroom addition. Now, the customer demand can explain in a more specific way his request, and in this about increase income, he require a high quality of activity in order to increase the number of client, and to reduce the inefficiency. And the designer transformed this customer attribute in the following functional requirement. So about high quality of activity, the designer proposed to reach a good architecture, and in order to reduce of inefficiency, the functional requirement is to guarantee cost and time budget. The solution is developed by designer, and the design parameter that satisfy the functional requirement are, in case of good architecture, is in need architectural planning and construction planning, and regarding cost, time, and budget, is in need project management in order to guarantee this limit. Now we check the solution using the first axiom. So by using the design matrix, we obtain a triangular matrix. Is a acceptable solution. You can see. So the functional requirement interaction with the design parameter in this way, we can develop a lower level of customer attribute, functional requirement, and develop a more specific solution. Now the customer require about high quality of activity to exploit the space, to use the space in order to guarantee all the activity, and a long-term investment. So he requires that the building of a solution doesn't need many maintenance activity, and minimum expensive. So he requires a high efficiency, high thermal efficiency of the building, and a high comfort for the client. The functional requirement corresponding that customer attribute are usefulness, about exploitable space, durability and comfort, about long-term investment and comfort, pleasantness, about pleasant places. Yes, customer require a beautiful and pleasant place for his client. So the designer develop a solution according with functional requirement, and the corresponding design parameter are about the usefulness. He propose a bedroom addition and services and relative services. About durability and comfort, especially about comfort, he proposes orientation of the building towards south, high thermal insulation for high energy efficiency of the building. And about durability, he proposed a durable material and technique. Regarding pleasantness, the solution proposed a contextual integration of the building in surrounding in order to guarantee a beautiful view and a pleasant place. So the solution is verified according to the first axiom. Is a triangular matrix, so the solution is an acceptable solution. We can develop the other functional requirement, the lower level of the other functional requirement. The customer attribute the customer require the following attribute. He wants feasibility of the project, that the feasibility of the project is guaranteed, and he requires that not over time and cost budget. He have some specific time and cost time budget, and he requires that limits are guaranteed. The functional requirement, the corresponding functional requirements are, in case of assured feasibility, to manage the change in order to reduce change during the process, and about time and cost budget, reliability, a planning of the process in order to guarantee this limit. The design parameters that correspond in this functional requirement are the following. About change management, the designer proposed a communication flow about the stakeholders in order to avoid change during the process, and a information flow in order that all stakeholders receive all information during the process. And about process reliability, the design parameter is a planning of process and a management of the process in order to guarantee time and cost time budget. We check the solution using the matrix. So the matrix is a triangular matrix, and we can develop a lower level of customer attribute and functional requirement. Now we are going to see the lower level about comfort, long-term investment, and minimum expensive. In this case, the customer is not able to specify his needs in very clear way. It needs more specialization about it. So we use this bubble to indicate the need of customer. The customer requires a comfortable room, little maintenance, and a safe structure in order to reach his goal. So the architect proposed this functional requirement according to the customer attribute. So comfort, thermal comfort, light comfort, durability. So about the shell, in order to guarantee a long duration of the building during the time, and structural stability and a safe building. So now we are going to see the solution and the corresponding design parameter. About comfort, the solution is a high energy efficiency building. The solution proposes insulating solution, very specific technique in order to have a high energy efficiency building. A good ventilation control system in order to have a high quality of the air in the building. Natural light control, especially the project, the architect proposed build opening, big opening, and a system of blind to control the natural light. And about acoustics, insulation acoustic is applied between the bedroom. Regarding durability, durable material as larch is a good solution, is a good material, wood material for external condition, and specific rainwater draining system. You saw before there are many green roofs and terraces, so it's important to have a waterproof system and a good water draining for durability of the building. And about structural stability, the architect proposed a concrete framework. We check the solution with the design matrix. The solution in this case is a good solution, is a diagonal matrix, so we can develop the other functional requirement in the same level. Now we develop the lower level about a pleasant place. Customer require a pleasant place for the client for increase his accommodating activity. So he require a pleasant appearance, good proportion, a beautiful view. The functional requirements that satisfy this customer attribute are a good formal quality. So in order to guarantee pleasantness and contextual integration of the building with the surrounding. Now we are going to see how a solution can satisfy this functional requirement. And about formal quality, the architecture proposed a solution, a balance between open space and building. So the building is located around open space, a swimming pool, a green area, and the solution uses the slope terrain in order to reduce the volume impact. In this manner, the building is guarantee a good contextual integration in the surrounding. The solution is a acceptable solution according to the first axiom. Now we are going to develop the activity of the workshop, develop the usefulness functional requirement and the design parameter corresponding to the functional requirement.
Now we try to work actively on the application of the axiomatic design in order to understand how this could support the decision making and make it consistent and let all these different stakeholders talk the same language and understand each other. So now, please, we are 8, so we divide into teams made of 4 persons each. So one would be let's say the investor, 2 the architects, a team of designers, and 1 the project manager of the entire project. So, and you should just maybe sit close to each other and try to understand, to work a little bit, just 10 minutes. It would be an easy work together.
4 and 4.
Yeah. Yeah, 4 and 4, and 2 will be the architects. Just decide among the team who's going to be the architect, who's going to be the investor, who's going to be the customer. And not really.
So for custom attributes, we use yellow.
So you could jump to that team. So 4 and those other 2 girls. Yeah. Okay. Could you please go up there to the, so even the other 2 guys, girls will be involved in the. So just to understand, you are asked to play this role. One will be the investor. Think of what we have said. you should, just a few words about the case study. The building has been developed, designed, and built using the normal process, design process, so standard way in which things are used to be done in Italy, let's say in Europe. So now the hotel is open, summer season, everything is good. We took the chance to use this case study to apply the axiomatic design, understand how axiomatic design could structure the entire process and maybe give support in the decision making. Okay, so this way is to you should think of what we said and described about the case study, and try to understand customer attributes, which could be useful, which could be listed or put in the fourth level of the exploit the spaces, usefulness, and bedrooms as the physical design parameter. So there are no right answers, but wrong answers. It's just a way you should try to coordinate all, act as you are the customer, and talk to the architect, telling him what are your desires, your wishes, what you want to put into your project, of course dealing with the usefulness of the thing. So what do you mean, being the investor, the owner in this case of the hotel, what do you mean for usefulness or better with the exploited space? You decided among all different type of solutions you may have to increase your income, to offer more space, to host more guests in your hotel. So you ask for 48 more rooms. And what you want to, how you want to, what would you like to put into this new wing? Only rooms, and which kind of rooms, what kind of things? You ask to integrate the new wing to the existing facility, because of course you want to put of the existing building, because you want to put facilities and offer, let the customer, the guests access those facilities being hosted in the new wing or in the old one. So that one issue, one that you want that the project will satisfy. Then you want the swimming pool and you want the wellness area. That's what this is the new service that you want to offer, and you want. You have an available area. You have seen that we are on the mountains, so you haven't got always the right space with the right dimension. The inclination, the slope could be a problem, and you have problem or requirements in terms of energy efficiency. So you can't put shadows or obstacles in front of other buildings. So you have that available space, and you want that this available space, which is not that big, can host, can offer enough area for all the rooms, the rooms which may have to be double rooms or even suites, then the swimming pool, and then even the wellness area. So those are thinking about the description of the project. The design of the hotel. Those are the things that the customer has to present and present clearly to the architect. Those are the must that the architect has to fulfill, to satisfy. And we try to let you clarify here. The architect. What has the architect to do or to put into the definition of the functional requirement in even the design parameters? He has to use the space, the available space, in an intelligent way, in the best way he can. So thinking of all the requests coming from the customer. Of course, flexibility is probably the solution that he has to put into the project in order to fulfill all the requirements, because the area is not that big. And even the space, the rooms have to be enough, large enough to be qualify the hotel as a high-level hotel. It doesn't have to decrease the offer of space of accommodation because it has to put more rooms and host more guests. Otherwise, you're going to change the type of guests the hotel will reach. And then these are our examples to describe the functional requirements, of course, of usefulness. That's the upper level which is linked to this exercise. The project manager, what has to do? The project manager, of course, has to be sure that the project satisfies all the requirements of the construction phase. Everything which comes after the design, after the planning. Of course, the project manager has to be sure that the site is accessible. We are on the mountains, remember that, and slopes, not many streets. And it has to be, the project manager has to find place for the storage part during the construction and even for the maintenance. Consider the place for the storing material on site. That's another topic. Problem, usually you are in the countryside, so you have a lot of vineyards and you cannot take over the vineyards because you have to store the materials. And you have to be sure that the installation of some elements like wide and huge windows may be installed. They have to reach the right place with the right machines and have to be installed. And even the maintenance systems and plant areas, they're usually not really liked by the architect, and they are really hide into the ground. But that is possible only if you take care of the entire process and you know what you have to put inside them. So those has to be fixed even by the project manager. He has to analyze the project and put them as functional requirements and even design parameters, because some of them impact the design. Should do it. So that's what you're asked to do. We have 10 minutes. Try to understand the customer attributes coming from the investor of the group, of the two teams. The architect has to decline them or translate them into functional requirements first, and then into design parameters. The owner will follow the entire process and will increase his awareness in terms of the decisions taken by the architect, supported by the project manager, in order to understand why one thing has been done in that way and not in the other one. And sometimes to understand why some of his requests are impossible to be satisfied. Sometimes they are just wishes. Sometimes you cannot have the minimum cost of the construction and the highest level of the quality. You have to find a compromise, and being involved in the entire process may make him understand or more aware on the let's say the giving a sort of rank of first issues and then other things which may be nice but not really necessary. Yeah, so afterwards, sorry, I forgot it. You have three kinds of cards. One is for the customer attributes. The second, let's say the green one are for the customer attributes. So they should be written by the investor. The yellow one, architects, functional architects and project manager, functional requirements. And then the violet one has to present the design parameters that the team has found to satisfy each functional requirements. And afterwards, you just jump in and we hang them on the flip chart and just describe us why you chose those 2, 3, 4 requirements and how you could link to each other. Then it's not an exercise, oh, you did it right, you did it wrong. It's a way in which we would like to let you understand how difficult it is sometimes to let those figures talk together and be really aware and how to say and somehow put ease the entire decision making. Sometimes someone, usually the owner, comes out at the very end of the design. Oh, but I didn't want it. I wanted 3 levels, 3 stories, and not just 2. Why did you do that? and you can't go back. Oh, you can go back and start again with all the design, but that's a very cost inefficiency, and it happens so many times in construction. Different guest needs. Some of them want a suite, some of them want just a double room. They just want to spend one weekend there, and some other wants a lot of space. And of course, all of them, the owner of the hotel wants them to reach easily all the services that is going to offer them. Of course, they are going to pay for them, and they should easily access to. Which are the functional domain requirements? How to translate those requests into functions? Suitable space, which is, of course, enough space for the rooms, and adaptable one. The flexibility of the to satisfy such different requests coming from the kind of guests going to that specific hotel. Of course, the flexibility of the wall is a very cost solution, and of course the customer, the owner, must have wanted it really. Otherwise, there were many other solutions like the sofa settings, with like bedrooms and access and circulation. That's the other function which has to be put into the project. Of course, the choice of put the wing south there, and in an inner part, the swimming pool, just give a sort of cozy space to the guests. What was a request, a solution coming from the owner. Design parameters connected to those functions. The sleeping area expansion has to be designed following all the let's say the design, the usual design square meters per room, space for the bedroom, for the bathroom, and those kind of things. The adaptability for bedroom to suite, in order to satisfy the flexibility. That's how flexibility has to be applied to. And bedrooms must be accessible from parking and from the central part, the central desk. And as you so there was that slope which was not really easily support the architect work. These solutions that we found, we had much more time than you have to analyze the project, and what we found seems to be acceptable or a good solution, so we could go further to the 5th level of the mapping and the composition of the problem of the design in the analysis. That was the outcome of the entire thing. We were thinking of going on with the change management, which just to complete the 4th level of the composition, but we had no time, so we think that we will just jump to the conclusions. But you have the coupling and this mapping at the end of the presentation, so you can check it if you want. These are the slides that I'm just skipping. Conclusions of the experience of the tutorial. What we found this at the end, which is not really complicated because we stopped at the 4th level of the composition, but it's what comes to evidence is the structure of the process, which is something really lacking in the architectural process. Usually the design, the architectural design is up to the experience of the architect, of the designer team. You have to do things which are one of a kind, very specific, very complex thing, and you have to combine so many different professionals. What you can get from one experience to put into another one is just the knowledge that you can gain because you find such as a great solution and you would like to apply it into other occasions, and the knowledge and the experience. More things you do, the best you do, and the ability of the architect, let's say the design team, is to be able to translate that experience and to make it worth even to other projects, which is not really useful, not really easy. of course, you might have to do one hotel and then one residential building, and you can't use the same solutions because they are completely different. And you have to take care to listen to the owner, if it is the owner, or to the investor, if it is the investor. And it's not really easy, and usually, most of the time, design parameters don't really combine or satisfy the requests coming from the customer. But you are used to do that, and you usually do apply that even in other projects, different projects. So it's really one thing which doesn't really support the effectiveness and the quality of the architectural design. So axiomatic design could support the entire design decision-making process, give a structure to experiences, and particularly we found four good plus in using the axiomatic design. We are just starting applying it into the architectural field, so it's really a starting point, not a conclusion of the entire analysis of the field. You may have an involvement of the customer since the very beginning of the project, making him aware of the decisions and how his choice can impact the future development of the design. You can't say, oh, you don't know it. You must have to, he has to be involved really, and he has to understand the reasons behind solutions. And even to say, no, I don't want it because I told you that I want 48 guest rooms, not 40, not 50, 48. Or 48 in this case because we know it, but I mean, clear minds on which are the main goals and what is just an add. And the second thing, axiomatic design can manage the design process through the decomposition and really ensuring that you can reach a solution which satisfies the initial goals. The structure is made that it's really that you exceed or not get the point or go very close to the vision that you have at the very beginning. Then the third point is that it's got the chance to reduce or minimize the interaction among the functional requirements. So it's, at the end it means to decrease the complexity. Sometimes you just analyze the functional requirements and you can understand that maybe they are more or less the same. So you can really define the topics, the big points of the project, and then decrease the complexity, which is really high. We just stopped at the fourth level and we did not really go into the plan system design, I don't know, the envelope design and things like that. We are just stopping at the very general level. And the last thing that we found is that, of course, the axiomatic design implies that you have to strengthen the correlation, the integration among the stakeholders, the stakeholders of the entire process. You have to be involved strongly. So this will at least ease the entire thing because they are forced to do things together.
I also think that you have to make information more transparent.
Yeah.
So, for example, right? So in the tradition, I'm not an architect. I think you are, right?
I'm an engineer.
So the traditional architect had certain things they had to think about, and other things were kind of outside of their experience base, basically. And so I think you gave a great example with this energy efficiency, right? Because most architects are not that aware, right? They don't know the actual data, you know, how much it costs, for instance, or what else it involves, and who supplies these things, which ones are good, which ones aren't. And so you have to pull in this information that they don't just have accumulated over these past 20 or 30 years. And so for the people, as they, you know, as you integrate the team, I think that kind of information, it needs to be available too, because other things they know kind of as a rule of thumb, right? You use this material versus that's going to make it so much more expensive. You add so much area, it makes it so much, all of those things they kind of know from experience. But this is now new stuff, and they just, you can't wait for them to accumulate the experience for 10 years before you make this. So you kind of need to bring in that information, it seems to me.
yeah, you don't have the chance to accumulate experience. It's not like you produce 100 of those products and then at the end you can get the
Right, and then you're on to something new, right?
Yeah. You have to start again from the beginning, yeah.
First of all, thank you very much for your presentation. I found it very interesting. When we were working on the axiomatic design of airport terminals, and we were researching it, I agree with the conclusions you are showing, and it was very interesting because when obtaining the physical solution for the design terminal, it's astonishing how when applying axiomatic design we can relate the shape of what we are obtaining with the customer needs. Because when I remember I made an inquiry to a lot of passengers in order to transform these needs into functional requirements, and to establish the minimum set of functional requirements was extremely difficult. But what is impressive is that proceeding with axiomatic design, we can immediately get why we are doing something according to the final user, because in architecture it's very typical that we lose why a certain shape is justifying a perceived need. So for example, we applied it for passenger terminals, we have applied for executive terminals to design, and for me what is very valuable is that everything is very well, traceability is not lost in the process, so you have very well connected the physical shape with the need, the functional need, and the customer perception. So I also agree with you that it's very, very powerful, and the key of accessibility, particularly when we have modular design and we need to have access from different modules, is very important to introduce it as a functional requirement, because otherwise we'll get lost in the whole infrastructure.
Then you need the facility manager to analyze the project.
So as you work on this, right? You have over time you develop experience, right? So you kind of have certain things that in principle you've solved already, right? It's kind of like subroutines in software development. I mean, do you use now some of the things that you have learned from the design of the passenger terminal to the executive terminal, for instance, right? Some of these sub things you should be able to.
What is very powerful in axiomatic design, and what I don't know if you agree for architecture, is that the solutions are not given. So what is given is the methodological framework. So when we first designed the airport terminal for 4 million passengers, obviously the functional surface needed to allocate all the passengers was completely different to executive. But what is beautiful is that the functional requirements are not separate. They directly come from the customer's needs. So sometimes the solutions you found in other applications are valid or not. For example, now I finished the design of the heliport and the emergencies one, and it was something completely different. What is common, what I found in all the designs we have achieved is the term of accessibility. When we have to build it, not only the customers, but also during the construction is something that we very often forget. But for executive, for example, apart from accessibility, was something completely different.
Yeah, but what I think is, it's very easy, it seems to me, and actually, I wonder if this process actually makes it worse, to skip some of the functional requirements, right? You start out with some, and then you start to develop some of the others, and then you may skip some of them, right? And that's really, if you have skipped those, then the rest of your design is kind of.
But yeah, I don't know if you agree, but something great that with this, to skip a functional requirement can happen always. Even in software, even in mechanical engineering. So what
It's
is
probably
good,
the biggest killer.
there is critical the hierarchy of the function of the composition, because in each level we have very well identified the number of functional requirements. So due to the fact that we are constantly going from the functional to the physical, we immediately can detect where there is
If
something
someone
missing.
is missing or not. I think that this methodology should be used as a standardized process. You can say this is a routine, as you said before, and this routine can be used in design workshops, for example, and to lead in these design workshops, you have to use a guideline, or this is our objective, to arrive to defining our functional requirements, design parameters in collaboration with planning actors and
So here's where I think potentially a challenge is, because I find that architects tend to think holistically. They don't. For them, this is probably torture. Right? Torture. It's very difficult for them to, and it's potentially also meaningless. Because it doesn't mean much to them to kind of do this very structured, because when they think about solutions, they think about them a lot of times in a very different way, right? So, and it seems to me, I've worked with quite a few recently, and it seems to me that they kind of have developed their own process, right? Which is roughly something like this, except for it's not as formulated. But so kind of to bridge that gap between this very analytical and kind of engineering process and the more holistic kind of aspect of what some architects use is potentially a real challenge.
Yes, the integration, I think, because the architect is a different approach and learn a different approach at the school. His approach is a solution-focused approach. So he developed very early a solution according to a simplified problem.
Yeah.
And after he changed repeatedly this solution and this problem until the solution and the problem are very clear. And it's difficult when you have a complex problem, and so I think this system, this design theory can add some specific activity as a decision-making activity, and architect can maintain his creativity, but can improve this creativity with design thinking.
And apart from that, it's not what is giving the shape of the solution is not the decomposition. What is giving the solution is the fact of keeping functional requirement independent through the solution. This is the clue. The clue is not that we are mapping and writing several level hierarchies. What makes the solution unique, and what identifies the best design is that we are, with the solution, keeping this functional requirement independent. And to that answer, there is only 1-2 solutions. And in architecture it's very visible, because at the end, the requirements can be very clear, and the solution that keeps this functional requirement independent, they are very thin. And this I've worked in several architectural stuff with airport terminals, analyzing existing solutions or considering new ones, and really keeping functional requirement independent. And what is incredible is that we give the functionality at the same time you're giving the shape.
Yeah.
You need to keep independent fluxes.
I think that the main advantage is that you establish a customer-driven process, which means that you start from the customer and you finish by process variables or design parameters. So you are always focused on the customer.
Exactly.
But I do only what the customer is willing to pay, or what he requires.
So sometimes that the architect just says it's got it's only and it doesn't mean I want the airport terminal, yes, but I'm making it as I figure it out, and it's not always comparable to what is the request. Sometimes that, but of course there are not so many genius in architectural things, and for the, let's say, the average normal things could be very helpful, could be, and could force all the partners to think about that. One thing that I found energy engineering, and it's like the approach just fixes the shape and pretends this to be a passive house. Not possible. If you're making, I don't know, a star, of course you have to understand that I cannot put 1 meter of insulation all around, and what about the summer behavior? So it's really, sometimes it comes to requests which are really just wishes. I would like to, I don't know, go to the moon but still live on the earth, and okay, it's not possible. And this could support that, even not to fix the solution and say, oh, you chose this on the first level, so you cannot change your mind. No, but you are aware that if you change your, you take a decision to change something, you know what this means in terms of design. And it could mean that you have to pay more, or that the process has got a delay, something like that. And it's not like, oh, come on, you said that you were doing this by 3 months. So that's the most thing. Very complex to apply to architectural things. Yes. Could be very, very theoretical sometimes, and it's really hard, as you said, with your experience, to translate into functional requirements and really understand how to put them. Very, very difficult.
It's very good.
Thank you very much.
Thank you.
Thank you.